Hi, in this video we're going to do some homework from lesson 5.3. We're going to do problem number 4, we're going to do problem number 16, and we're going to do problem number 26. So let me back it up here to number 4. Reading the directions in the book, it says, for each statement, write an equivalent statement in logarithmic form. Alright, so this is a matter of identifying your base, which is 2, your exponent, which is 5, and this is going to be our argument in our logarithm form. So in logarithmic form, you would have the exponent all by itself. The exponent equals the log, which is base 2. If you think about it, the base of the exponent is 5. The log has a base of 2. We write the 2 down below the word log. Don't put it even with it. It goes down below the word log. So 5 equals log base 2 of what? And that base 2 is of 32. This right here is the switch from exponential to logarithmic, and that's all it's asking you to do in this first example. So I'm going to go ahead and box this example. Not going to have a fill in at all, and this problem is complete. Of course I can't box it. There we go. Alright, and that one means this one is complete. Alright, we're on to number 16. This one has a different direction, just slightly. For each statement, write an equivalent statement in exponential form. So this time we're going to go backwards, and we're going to write the logarithmic form in exponential form. Well, in this case, you have to identify the base again, okay? Well, the base is this little number down here at the bottom of the log, which is the number 3. So we have the base, which is 3, the exponent. If I bump it back to the previous example, I want you to remember the exponent was the number all by itself. Well, in this problem that we have, the number all by itself happens to be on the other side of the equal sign. So that means that this guy is your exponent. So it's 3 to the 2/3 power equals. Now, the number all by itself over here is your argument, which in this case is the cube root of 9. And that's all we have to do to answer this question. We wrote it in exponential form. So I'm going to go ahead and box this one and say this problem is complete. So I'm going to bump this on to number 26. Number 26, this time it says solve each equation. This problem starts off with a logarithmic. One of the ways to solve a logarithmic problem from time to time is to actually change it back to its exponential form. So I'm going to change this back to its exponential form by identifying the base. The base is the number below the log, which in this case is 16 over 25. Now, as 16 over 25 is the base, then that means that it must have an exponent. What is the exponent? The exponent is across the equal sign. It's all by itself, which is negative 3 over 2. The argument in this case is just x, and that's what goes over here on this side of the equal sign. Our job is to solve this problem. All we have to do is whittle this thing down using algebra to get down to what x is, because x is already by itself. It's just a matter of figuring out what this number is over here. One of the rules we have says that you can flip this fraction over. You can make it 25 over 16 as long as you take your exponent and make it change its sign, from this case from negative to positive, and it's still equal to x. These are equivalent to each other. You also have a rule that says if you have a 2 on the bottom, that means that you are in the denominator. That means that you are taking the square root of these numbers. So in this case, this is the square root of 25, which is 5. This is the square root of 16, which is 4. Now keep in mind, I'm saying square root. I'm not saying square. If it's in the denominator, this is a root. It's telling you to take the square root of these numbers. Well, I did that. I still have parentheses because all this is still being raised to the 3rd power. And it's still equal to x. If I'm going to raise each of these numbers to the 3rd power, that would be 5 to the 3rd power, which is 125. And this would be 4 to the 3rd power, which is 64. And we have now worked this thing down to say x is 125 over 64, and that completes this problem. So I will go ahead and box this problem. And that is it. This video is done for these 3 problems.